Hello. In this video, we want to find the following. We have the limit as x goes to 1 of x squared minus 2x plus 1 all over x minus 1 cubed. Well, here's the thing. We can't really just plug in the 1 because 1 squared minus 2 times 1 plus 1 is 0, and 1 minus 1 is 0, 0 cubed is 0. We get 0 over 0. So let's see what we can do with this. Notice that the numerator can be factored. So this is going to give us the limit as x goes to 1 of, now it's a degree 2 trinomial, so a lot of times we want to begin with two sets of parentheses. And in those two sets of parentheses, this is a plus sign, meaning that we need to use the same sign, and that's what sign they are. So they're both going to be minus. And because it's x squared, we just have an x and an x. 1 multiplies to 1 and has a sum of 2. Well, 1 plus 1 is 2, so 1 and 1. But notice that the numerator is x minus 1 times x minus 1. That's x minus 1 squared. So this is actually what we call a perfect square trinomial. And it looks like this: a squared plus 2ab plus b squared. And its factorization is just a plus b all squared. And to get that, all you do is basically just take square root of that, and then use that sign between the two and square. And you're going to get the following. We have the limit as x approaches 1 of x minus 1 squared all over x minus 1 cubed. Now, notice that in the numerator we have 2 of the x minus 1s. In the denominator, we're going to have 3 of the x minus 1s. Notice that that means all of the x minus 1s cancel in the numerator, and 2 of them will cancel in the denominator, leaving you with 1 in the denominator, because 3 minus 2 is 1. So 2 of these canceled and 2 of those canceled, and that left us with 1 more. So really, this is just the limit as x approaches 1 of 1 over x minus 1. Now here's the thing though. We need to figure out what is this going to do, because we have 1 in the denominator. Well, not really 1, but really close to 1. So if you're getting 0 in the denominator, you're actually blowing up to infinity or down to negative infinity. We want to look at this as what happens in both directions. So looking at this as the limit as x goes to 1 from the left-hand side of 1 over x minus 1. We need to take a number that's to the left of 1 and plug it in here. That's something that's to the left of 1 and kind of close to 1. Just it usually helps be close. So this is going to give me something, it's not really equal to, let's just say it's similar to 1 over, and then instead of x, let's replace it with 0.9. So what is 0.9 minus 1? 0.9 minus 1 is, well, negative 0.1. So this is the same as 1 over negative 0.1. And top that into the calculator, that's going to give you a negative 10. Now if you give this to be a 0.99, that would have given us a negative 100. 0.99 would be negative 1,000, and so on and so forth. But the important thing here is that this is negative. So this is telling me that the limit as x approaches 1 from the left-hand side of 1 over x minus 1 is going to equal negative infinity. Let's do this again. Let's look at this as the limit as x approaches 1 from the right-hand side of 1 over x minus 1. Well, we want to have it to the right of 1, so it needs to be larger than 1, making that, let's say, 1.1. So that's going to be similar to 1 over 1.1 minus 1, which gives us making it similar to 1 over positive 0.1, which is going to be around 10. But notice that if we made that 1.01, that would have been 100, and then 1.001 would have been 1,000, and so on and so forth. So that's telling me that the limit as x approaches 1 from the right-hand side of 1 over x minus 1 is going to give you positive infinity. Notice that negative infinity is not the same thing as positive infinity. In other words, it's going in opposite directions. whichever way it happens to look correctly, I'm not really sure. And so that's telling me that this simply does not exist, D&E. And that really is it for this. But here's the thing, we didn't actually need to go through all of this over here because of one thing. If you look at the exponent here, the exponent in the denominator on this one is 1. Odd means opposite. Even means same. So opposite, it's opposite because it's going in opposite directions. If this was squared right there instead of to the first power, then these would have either been both positive infinity or both negative infinity, and we would say that this would equal either positive infinity or negative infinity. But it really doesn't matter in this case. But that's what would have happened. Now, another way of looking at this would be to graph this on the calculator, and if you graph this on the calculator, you're going to see at x equaling 1 a vertical asymptote, and something to the left it's going down towards negative infinity, and to the right it's going up towards infinity. Something like that. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.